So I'm gonna go over titration and titration curves with you. So to set up your titration curve, or actually just reaction, you usually have your flask. So that would be this here. And in that flask, you'll have a known amount of HCl, but you won't know its molarity per se. So the point of a titration curve is to see how strong your acids or bases are. So what else is going to be in this flask? Well, you want to use an indicator and a specific indicator that will change color at what you think the equivalence point will be. So phenolphthalein is a great indicator for this. And the reason why phenolphthalein is such a great indicator is because it is colorless below 8.5 pH. And anything above 9 pH, it's going to have like a really nice magenta color. So let's talk about what you'll see when you come close to your equivalence point or endpoint. So what's going to happen is in your flask, it's just going to appear colorless. You won't really see anything. Once you get close to your endpoint, let's say you're just looking down from it here. It's all colorless, like water. You might start to notice when you do a drop, you might see a swirl of color. And when it mixes, that color would disappear. That's telling you that you're close to your endpoint. So at this point in your reaction, you want to do small little drop-wise amounts of NaOH into the flask. If you notice that after a couple of seconds that swirl doesn't go away, at this point you'll want to close your burette and swirl your flask. If you notice the color remains something like this, you've hit the mark. So that would be a pretty perfect titration. If it's a little darker, like this, that's okay. It's reasonable data to include in your graph. But if you're getting something darker like this one, you've gone past the mark a bit. So the data won't be very accurate. If you get this color, you've definitely overshot the mark, and we probably wouldn't use that data point. This color here, this one's just pretty. But unfortunately, that is garbage data. All right, so let's talk about what your graph is going to look like. So as you're adding NaOH into your flask, you'll have a pH reader. And say every 2 milliliters, you'll want to record what's going on in this region. But let's look at that very first data point. What do you notice about this data point? Let's look at where it is on the pH, the y-axis. So we see that it's a little bit below 1. What do you think that signifies? Probably a strong acid. So HCl is a pretty strong acid, so that makes sense. As we move more to the right, so we're adding more NaOH, what is happening? Well, we've got this reaction going on. This is an acid-base reaction. More specifically, it's like a neutralization reaction. And why do we call it that? Well, let's think about what the products are going to be. Okay, so we've got NaCl, which is sodium chloride. That is a product of pH equaling to 7. Same with water. So those are pretty neutral compounds. And if we look at the reaction below, we're taking a look at the ionic form of this reaction. So we can see that Cl cancels on both sides, sodium cancels on both sides, and we're just left with hydrogen ions, hydroxide ions, and water. So really, this graph is indicating the concentration of H+ ions in the reaction mixture. And that kind of makes sense because if we look at the graph, We know that if we have a low pH, there should be lots of hydroxide ions. As we move up the scale, what that's saying is that we're going to have a decrease in H plus ions. So as we approach the 20 milliliter mark for addition of NaOH, we see something drastic happening. The pH starts to shoot up, and what does that mean? Well, we know we have an excess of H plus ions here. So every time we add NaOH and we get that OH molecule, it's going to quickly grab one of these H plus ions and turn itself into H2O. But remember, we have excess H plus, so there's still going to be some H plus here. At this point, the reaction has come to an equilibrium, or we say an equivalence point, which means we have equal amounts of HCl reacting with equal amounts of NaOH. So they have the same equivalence. We notice that now we start to have excess OH. So that's going to consume these ions, and what we're going to see in the product is our water plus excess OH. When we get up to this point, we see that it's at a pretty high pH. What does that indicate? A strong base. So by this point, we probably have very trace amounts of our H plus ions. So there's one more thing that I want to go over, and that is the endpoint. So the endpoint is something that we see. That's where the indicator comes into play. Once we see that color change, we can say, okay, we've reached an endpoint. Now, what's important to know is that the endpoint will never be down here. It will not be over here. Where do you think it will be? Remember, we said that phenolphthalein has a color change between 8.5 and 9. So we'll most likely see a color change happening around here. Now, that's a pretty small window. What do you notice about that though? Well, we know that it's going to be our endpoint because that's what we visualize. But it also surpassed the equivalence point just slightly. So as you keep adding more and more and more, you'll start to see that the color is going to go to a very dark, pretty magenta color. And you want to end your titration when you notice there is a plateau happening here, and that means all of your H plus ions have been consumed. Much like over here when you started off with 0 OH ions in the beginning. Well, I hope that helps, and message me if you have any more questions. Have a good night.